Hello and welcome to this Python tutorial. Today we're going to implement the naive Bayes model on Python. So let's start right now and let's find out about the results. So we're going to go to File, Explorer here to set our folder as working directory. So we'll go to Machine Learning Easy folder, Part 3 Classification, Naive Bayes section, and here we are. Make sure that you have the social network at CSV file, and if that's the case, click on this button to set this folder as working directory. Now we're going to take our classification template to be efficient and get the final result even quicker. So we'll copy this and paste all this here. And now what we only need to do is change a few things. First, we need to create our classifier here. Then we need to change the name of the classifier here. So it's here naive Bayes, and same as here. Naive Bayes. So yes, I'm doing that right now so that we don't forget. And now we are ready to change the last thing, which is to create our classifier. And you're going to see how it's going to be so simple. We will just need to write 3 lines, well, as usual, as for all the classifiers we made so far, but you will see we won't have any parameters to include. I'll show you. So remove this, and then let's import the class for the job. So the class for this job is the Gaussian NB that we want to import as a class. So let's do this. It's actually from the scikit-learn naive Bayes library. So we're going to write here from sklearn.naive Bayes import Gaussian NB. And that's it. That's the class that we're importing from this library. All right. And now let's create our object. So our object is, well, we call our object the classifier. Classifier equals, and then of course we're going to call the class here Gaussian NB. And now if we press Command I to inspect the Gaussian NB class, look at what the arguments are. Well, actually there is no argument. No argument. So that's why it's so simple. Here, as you can see, we have an example and we only need to call the class. We don't have any parameters to input. So that's kind of cool. We don't have anything to do here. And so now let's fit our naive Bayes classifier object to our training set. So to do this, as usual, we start by taking our classifier object and then use the fit method to fit the naive Bayes classifier to our training set. So xtrain here and ytrain as usual. Nothing changes. So now it's ready. We are ready to execute the different sections of this code. So let's do this. We're going to start by executing all the pre-processing steps. So it's from here to the top. All right. And now Command or Control plus Enter to execute. And perfect. All executed properly. We can check in Variable Explorer that we have all the right sets created. So we have our data set here, our training set with xtrain and ytrain, our test set with xtest and ytest. And so everything looks great. We can even check that xtrain is scaled properly. Yes, we can see that it is scaled very properly. So here is the age column and here is the estimated salary. Okay, and now let's select this to create our classifier. So Command and Control plus Enter to execute, and our classifier is now created. So perfect. As you can see, remember for the other classifiers, we had all the parameters selected by default. Well, here, since there is no parameter, there is just this Gaussian NB here in the output. So everything looks great. Everything is easy. Awesome. Now let's select this to get our vector predictions. Here we go. Whitebread created. Let's look at Whitebread. And let's open as well ytest so that we can compare the two. It looks great so far. We can see that the 6 first predictions are correct predictions because here are the true results, the true observations. The user didn't buy the SUV in reality. And here the 0 are the 0 predictions. That is, our classifier predicted that this user didn't buy the SUV. So that's correct predictions. Same for the 7th user. The 7th user bought the SUV in reality, and the prediction says the same. Okay, so the 8th is correct. However, the 9th is not correct because in reality, the user didn't buy the SUV, but our classifier predicted that this particular user bought the SUV. Okay, so as usual, that's not the best way of looking the incorrect predictions. The best way is to take our confusion matrix and have a look inside. So that's what we're doing right now. We're selecting this code section here, generating the confusion matrix. Here we go, confusion matrix created. Let's have a look. And in a flashlight, we can see the number of incorrect predictions. 7 plus 3 equals 10 incorrect predictions out of 100 incorrect predictions. So not too bad, but we can do better and we will do better. So let's press OK. And now let's get straight into the most fun part, which is the visualization of all the results. So let's select all this and press Command and Control plus Enter to execute. And here we go. Wow, that's actually a beautiful curve. That's what I was telling you. I was telling you before that, we had this straight line for the logistic regression, and then we had this KNN prediction boundary that contained a lot of irregularities that made it not that beautiful. But here we have a beautiful curve that actually, let's enlarge this to look at the result. So yeah, I was saying here we have a beautiful curve, a very smooth curve with no irregularities. Well, that's proper to the Navie-based model. That's because of the way Navie-based model work. So not only it's a beautiful curve, but also it manages quite well to catch these older users with a low estimated salary who actually bought the SUV, which the logistic regression and the SVM couldn't classify correctly because there were linear classifier and therefore the separator, the prediction boundary was a straight line. But here it's making a curve, so it manages to catch most of them. We still have some of them who are the most rebellious and who managed to beat the Navie-based classifier, but anyway, it made a pretty good job here. Now a good exercise for you is to try to understand how the Navie-based model managed to classify all our data points which are nonlinear separable in this red region and in this green region. And that's based on what you learned with Kirill in the intuition tutorials. Try to understand how Navie-based did that by applying the theory that you learned with Kirill to this particular set of data points and this particular problem. That's a very good exercise that will shape your intuition of Navie-based even in a better way, and you will become even more machine learning experts. Okay, so that's the training set results. So let's have a quick look at the test set results. The test set results are right here. So let's have a look. Let's select this from here and press Command and Control plus Enter to execute. And not bad at all, not bad as well. Let's look at them. All right, so that's the test set results. We can see that most of the red users, that is the users who didn't buy the SUV, were predicted correctly by the Navie-based classifier because they ended up in the red region. And same as the green users, who are the users who bought the SUV and were predicted correctly because they fell into the green region. Of course, we have some incorrect predictions, and if you want, you can count the number of incorrect predictions, that is the number of red points in the green region and the number of green points in the red region, and you will find the number of incorrect predictions we found in the confusion matrix, which was 10 incorrect predictions. Okay, so do this exercise, try to understand how Navie-based obtained such a result. So, that's the exercise of combining the theory and the practice by understanding how the theory works onto this particular practical problem. Thank you very much for watching this tutorial. I hope you like this new curve. This is kind of a new result we're obtaining here. And we are not done with the surprises, because you're going to see that we will obtain some more different shapes of the contour, that is, of the prediction boundary here. You're going to see it will be with decision trees and random forests, and I can't wait to show you this. Until then,